Alright guys, let's get back to the Leetcode question. So the Leetcode question is an easy one, which is a good thing. And then let's read the problem. So it's a count partition with even sum difference. So we're given an integer array of nums of lunch, and we just given a numbers of integers arrays. Well, a partition is defined as the index I, where the index I is starting from the 0 to the n-1. That means we're given a 0 index array, splitting into the array into two non-empty subarray, such that our left subarray should be start from this 0 and n on the I. The right subarray should be start from I plus 1 and any in the n-1. So we have to return the partition where the difference between the sum of the left and right array is even. So to work on that, so I was thinking about, alright, let's try to dry run the problem. Let's consider like we have an array in here, which is a 10, 3 and 7 and 6. So let's consider we have a 1 then to make a subarray between the left and right. Let's consider this is a subarray. I don't know why I'm so bad at drawing. Alright, here we go. So yeah, so the thing is by checking that according to the arrangement given by the 10, so the right side is the 13 and 26. So 10 minus 26 is a minus 16, which is even, and that is divisible by 2. Yeah, that is a 1. Okay, let's consider the answer now is a 1. We have a 1 at the moment. So now we have 20. How can I move that? Have a 20 in here. The right side is a 16, so 20 minus 16 is a 4, which is also even. That will make us the result in 2. So next step is we have 23, and then we have 7 plus 6, 13. So 23 minus 13 is 10, which is even. That is also true. Next step, and then 13 minus 6, which is a 24. That make us oh yeah, I forgot to increment it here. So in here we also saw the 1 then, which is the 13 minus or 23 minus 13, which is 10. So our result in here is 3. So move to the next step. That would be the 20 minus 6, which is a 24. That would be the result in 4. Yeah, that is our base case. So if we move to the next problem, next example, that is like 1. 1 minus 4 is 3. That is not even. 3 minus 2, that is 1. Yeah, there's no partitions in here. Oh, let's check here. So we are having like 2 and 4 and 6 is 10, 18. Let's try to dry run this one. Let's do this. Let's gonna do 4, 6, and 8. So we have like 0 at the beginning for the reset. 4 and 6 is 10. 10 plus 8 is 18. 18 minus 2 is 16. So we are resetting a 1 in here. And then 2 plus 4 is 6. And then 6 plus 8 is 14. 14 minus 6, we're resetting in the 8. So that is divisible by 2. So our result became 2. So next step is a 12 minus 8, which is a 4. 4 is also divisible by 2. That's why we are resetting in 3. So by doing that, we can start writing the code already. Let's consider that we have a count called nums.count minus 1. Yes. Let's call as a, yeah, let's index, because I don't want to use the variable names as a count. And then let's go through like for index in 0 through less index. So we are initially I'm thinking to take the less index in here, but let's go like left portion. That will be the nums of 0 to index. We can just cut the total sum by getting the reduce operator with the plus sign. And then for the right portion, we're also taking like nums of starting from the index plus 1 if I'm not wrong. And then we're gonna go through like a less index. But the thing is, if the less index became the one, we are having the index out of bound. So we're gonna go through the till the less index. Just take it like a less index, and then we can get the total by using the reduce operator. And then we can calculate like left portion detect by right portion. So we don't need to care about like that is a minus or black, so whatever it will happen, that will do, and divided by modulo by 2. If begin to 0, we need a one variable in here. Let's call like reset 0 1. At the end, I just return the reset. Yeah, then if we submit that will be the O of n for the time complexity. And alright, sorry for that, I was always late to submit that video. O of 1 for the space complexity. Let's check. Yeah, O of n squared for the time complexity and O of 1 for the space complexity. But I have very mind-blowing answer for you guys. If we really want a very simplest mathematical solution, how can we do that? So let's check the constraint first. So the constraint is given that we are given at least number length will be minimums more than greater than 2. That means at least have a 2. Right, we can just get the total. Let's go like 0 and plus. And then if total is divisible by 2, it's not divisible by 2, we just return the 0. That means like whatever the total combinations comes in here, if it is not even, and that's return to 0. If yes, we just return the num.count minus 1. Let's try it. So that would be the O of 1. I think O of n, since we still run through it in reducer. And then it will be the memory will be the O of 1. That is my guess. Let's try to submit is solved or not. Yes. Unfortunately, I cannot see the analysis anymore. So pretty sure that runtime is O of n, and then space complexity will be O of 1, since we don't use any other extra memories in here. Yep, that is pretty much for it, and see you in the next one. Bye.